Okay, two proportion z-test and interval. I suggest for you to do these two proportion z-test and interval first before you watch the duration of the video so that you can get more feedback. All right, so the one that I'm going to have you try is 2006 number 2. If you'd look that up on the internet, Form B, or you can look at it here and just don't look at the answers, and then stop my video, do the problem, and then come back to it. Okay, this particular problem, though, I'm going to tell you, only ask for a 96% confidence. You can see that. And on the AP test, you would just do the 96% confidence interval. You would not do the hypothesis test and the interval like I'm about to do. I'm just doing it for demonstration purposes only. Okay, I'm going to start with the actual test. So the first thing I'm going to do before I actually do the test is I'm actually going to just put it into my calculator. So I'm going to use the information that I gained from reading the question. So we'll read through the question and you can see as you read through the question, I'll go through it and help you out. I got the 188 out of 200 to be my P1 hat. So I'm going to call this one my X1 and this one my N1. And then I got the 180 out of 200 to be my P hat 2, which is X2 and N2. With this, you need a couple things. Well, that's all you need for your calculator, honestly, and then I'll go through everything else in a second. So let's go to our calculator. So we have, and by the way, if you had P1 because I had this as my P1 as day shift and P2 as my night shift. If you had them opposite, that's fine. It's just going to show reverse. It's going to be like I'm telling you I'm 5 inches shorter than you and you say, no, I'm 5 inches taller than you, Miss Brown. Well, we're saying the same thing. So anyway, let's jump over to the calculator. All right, so the calculator here, I'm going to open up, I'm going to do it from a list and spreadsheet. You can do it from a calculator page or a list and spreadsheet, but if you do it from a list and spreadsheet, it will draw it for you. So statistics, stat test, this is a 2-prop z-test, and we have, just checking, my P1 was 188 out of 200, and my success 2 was 180 out of 200, and my alternative hypothesis, which is not equal to, and I forgot to show you why it's not equal to, but I'll show you in just a second. I'm going to go ahead and hit shade so it'll draw it for me. Okay, and there I have all the information I'm going to need in a second. So I have my z-score as 1.47442. I have, let me just take a screenshot so I can highlight here for you where I'm talking. My z-score is 1.4472. My p-value in a second is going to be 14%. Now I want to tell you this is 7% and this is 7%, but both of them together are 14% because it's a not equal to. My P1 hat is 94%. That was that 188 out of 200. And that's P hat 2, that's that 180 out of 200. It did the math for me. Now this P hat is called my P pooled, which I show you on mine, which is P hat C. And the way they got that was 188 plus 180 over 200 plus 200. Literally what they did is took my P1 hat plus my P2 hat and pooled them together. And that's the P hat statistic we're actually using in this particular problem, which comes out to 0.92. And there's my N1 and N2. And so it's really super convenient to have this done before you actually start the test, and then you're just going to refer to your calculator the whole time. All right. So let's jump back to ours. Okay, so you're first of all going to start off with P. P stands for parameter. And your parameter, or actually parameters for this one, you have two parameters because it's a 2-prop z-test. We know it's a 2-prop z-test because I am comparing two proportions to each other. A 1-prop z-test compares one proportion to the population. A 2-prop z-test compares two proportions together. So I'm starting out always in a 2-prop z-test in our course. We have my hypothesis, my null hypothesis is P1 equals P2. My alternative hypothesis is always P1 and P2, but this here, I could have either a not equal to, a less than, or a greater than. But the reason I know this one's a not equal to is because it says right here, there is a difference. Is there a difference? It doesn't say, is day shift less than the night shift, or is night shift less than the day shift, or greater than. It doesn't say that. It just wants to know if there's a difference in the productivity of the two shifts. So that's why I'm going with the not equal to sign. Okay, so it tells us in the write-up, if you read it, that the random sample it's taken, it says it there, so you're just going to say both and put a check or something. Make sure you don't just put random sample. Put that a random sample is taken, or that a random sample of 200, I mean, really what you should write, a random sample of 200 is taken from both day shift and night shift. So that's really what you should do. It's a little bit better because we know there's 200 and 200. Independence. We really, the way that we're showing independence is through random samples and my large sample size. That's really how we're showing independence. So this sentence, it's independent from the next, is really not necessary because I'm showing independence through random samples and NP/NQ. But I have, so for L, I have NP/NQ, so that's my P hat pooled, excuse me. And this is my N, and this is P hat or Q, excuse me, 1 minus P hat, which is my Q hat pooled. And that's my N1. Now, really, I was lazy because N1 is equal to N2. I said, oh, look, both the same, it's going to be the same thing. So I just said N1 is equal N2. But to be more complete, I really should have said 188 and 180 are both in samples 1 and 2. And that's the reason that where large sample is met. The last one, I did do it correctly and I wasn't lazy. I said 200 times 10 is less than all day shift parts. 200 times 10 is less than all night shift parts. And then I said, okay, all conditions are met. Let's proceed to the normal model. And the normal model that we're doing allows us to do what's called a 2 proportion z-test. And so the first thing I have to do is find my z-score. So the formula I'm actually using is P1 hat minus P2 hat minus P1 minus P2 all over the square root of PC hat, which is my P pooled, QC hat over N1 plus PC hat QC hat over N2. Now this, you can find this formula on the back of your stats formula chart, and you'll see this one here. It says where P1 equals P2, we are going to use, and it tells you it even gives you that even PC is X1 plus X2 over N1 plus N2. Like it even gives you what PC hat is. So that's super helpful. P1 minus P2, guys, look at the ha. If, the ho, I'm sorry, didn't mean the ha, I meant the ho. All right, if P1 equals P2, then P1 minus 2 is always 0. In our case, that's what we're doing. That's not in all 2-prop z-tests, but all of our 2-prop z-tests will be there. I'll say the only time you might see where P1 does not equal P2 would be in what they have in number 6 on the AP test. They have sometimes, it's called an investigative task, and they give you something kind of weird that you haven't seen before. You've done all the concepts, but it might be kind of a little bit something you haven't seen in class. So in that case, you might have the proportions not equal to each other. So that's a possibility. But in our class, what we're doing, you're going to be P1 equals P2, and you're not going to even really worry about it, okay? So I just put the numbers in. This is, of course, my P1 hat. This is my P2 hat. This is my PC hat, and this is my QC hat. Of course, QC is just the opposite of PC. Same thing here. And, of course, that's P1 minus P2, and that's N1, and that's N2. Often it's written like this, the bottom part, where you can write PC hat QC hat 1 over N1 plus 1 over N2. It's a little bit less writing. That's also mathematically equivalent to what we have written here. So either way. Okay, so once you have your z-score here, you get 1.47, which we look over here. We already knew that. That was 1.47. We knew that's what we were getting. And in fact, that's how I did it, is I wrote all this data in, and then I just looked back at my calculator and said, oh, that's 1.47. And then to draw mine, it reminds me that I have to draw it on both sides. Now, it's often people forget to put on both sides because it only because you end up getting z equals 1.47, so they put the 1.47, but they forget because ha is not equal to, that's a two-sided test, and it's going to be on both sides. So it's going to be on both sides here, and that's 1.47 and negative 1.47, and the p-value is 0.14, like was shown already. So the next step is obtain your p-value. The O stands for obtain p-value. And the p-value we obtained already at 0.14. And then you're going to make your decision. And your decision is about the p-value. Since the p-value is equal to 0.14, I'm going to, that's greater than alpha. And that decision is fail to reject HO. I'm failing to reject P1 equals P2. We do not have convincing evidence that there is a difference in proportions of the parts within specifications produced by day and night shifts. All right, so that's the end of our hypothesis test. Let me just go through, I don't think I was explicit of what phantoms actually stands for. The P stands for parameters, H stands for hypotheses, and then A stands for assumptions and conditions. N stands for name the test. T stands for test statistic, and your test statistic you're finding is Z. O stands for obtain the p-value. It looks like I lost some of my letters. M stands for make a decision, and S stands for state conclusion in context. Okay, next I'm going to perform a 96% confidence interval. By the way, I do want to show you that I used 4% for alpha. The reason I did that is because on my 96% confidence interval, 96% is in the middle, and we're doing a two-sided two-sided z-test. So there's 2% on this side and 2% on this side. So if I found my z-score to be anywhere in this area or this area, I would reject. That's the rejection region. So 2% plus 2% is 4%. So that's why we used 4%. If it was a one-sided, if my ha was P is less than, right? Then it would just be this side, and I would have my alpha would then be 2% because that's the only area of rejection region. Meaning if my p-value was anywhere in this area, I would have A in the rejection region. So my p-value, if my p-value were in this area or this area, that's the rejection region. But you can see my p-value was not in that area. My p-value was here. And here, right? And so it was not in that rejection region, so therefore that's why we failed to reject. Where it lies, where the actual value is, like where it lies. Okay, going to the two proportion z interval. So if you notice on the two proportion z interval, here's two proportion z intervals where I'm headed. Go ahead and stop my video and try it. And the acronym is PANIC that you're going to do. All right, so the P is parameter, and it's identical to the hypothesis test. The A is assumptions and conditions, and you can see the different colors the blue color is the same as what I had in the hypothesis test. The pink one is what's different. Because now instead of in the blue, in this one, remember what we did was we used NP, we used the pooled statistic, which was P hat C, and Q hat C, which is the pooled statistic, where this one, we are using P hat. So I'm concluding that's my P hat 1, N1. That's my Q hat 1, N1. My P hat 2, N2. And my Q hat 2, N2. A little tedious, but not difficult. Just like before, let's go ahead and throw this into the confidence interval. Remember, we know my X1 is equal to 188. My N1 is equal to 200. My X2 is equal to 180. And my N2 is equal to 200. And the confidence level we're doing is 96%. The reason we're doing 96% because that's what it asked me to do right there. So 96%. So let's jump to our calculator. I'm just going to do this one from a calculator page to show you guys you can do it from either one. Stats, confidence interval, a 2 proportion Z interval. So we had 188, 200, 180 at a 200, and my confidence level is 90%, or excuse me, 96%. So all of this data, negative 0.016 to 0.096, that's going to be my confidence interval. And then my P difference, that's R. Okay, so this is obviously the lower part of the confidence interval, and that's the upper part. The P difference, that's just the 188 over 200 minus 180 over 200, and that actually equals 4%, because actually if we did it like this is 90. So that's what P diff is. Margin of error, that's the plus or minus all of that stuff that we're going to do in a second, the Z star, and then my standard error. And then that's the margin of error, all this stuff, the plus or minus puff. And then, of course, the P hat 1, that was the 188 over 200. The P hat 2, that's 180 over 200. And one, of course, is I have 200 samples from the day shift and 200 samples from the night shift. So I'm going to go ahead and use this data. When I come to my confidence interval, finding the confidence interval, I'm not going to have to use my calculator at all because I'm just going to refer to this chart that I've already done in my calculator. Okay, so I've done RILT and found that all conditions are met to proceed to the normal model, and I'm naming, next one is name the interval. And it is a 2 proportion Z interval. And this formula, P1 hat minus P2 hat, that's what those are, plus or minus the critical value, which is Z star. And this is going to be P1 hat Q1 hat over N1 plus P2 hat N or Q2 hat over N2. And that's what these numbers are. Again, you see that this value that I already got was from my calculator. Now, the way I got 205, my calculator, when I did the 2 proportion Z test, did not give me that. So I'm going to show you how I found that. I did that with a Z star inverse norm. The reason I used 0.98 is because this is not a confidence interval calculator for, inverse norm is not a confidence interval calculator. It's a regular calculator that's just doing the percentage and the Z scores underneath the curve. And my confidence interval is doing the center 96%, but I need this value right here. So if I put in 96% into my calculator, it's going to stop me somewhere like here, and it's going to give me this value because it's going to do, that's only 96%. So I need to remember I've got an extra 2% here and 2% here. And since my calculator starts from here, I'm going to go past that 2%, past 96% to get me that, and that's a total of 98%. So I'm kind of tricking my calculator there. The reason we didn't have to do it when we found my 2 prop Z interval and I put in 96% here is because it had actually asked me for my confidence level. It was completely programmed in order to know that I'm looking for that center 96%. Inverse norm is not programmed to do that. It's programmed to start from the very beginning. Anyway, so that's how I get out 205. Mean is nervation, this because for Z-scores, my mean is always 0, my nervation is always 1. Margin of errors, this here that I'm circling, the plus or minus, if I did that math out, I would get that margin of error as 0.055565, what I got in my calculator. All right, so now time for my conclusion. We are 96% confident that the true proportion of parts within specifications made by day and night workers is between, 1.5% lower. The reason it's lower on a 2 proportion Z-test, if it's negative, it means lower, to 9.6% higher than the night workers. So essentially, guys, what I'm saying is really there's no difference because I'm saying, hey, it's sometimes lower, sometimes higher. Since 0 is contained in the interval, we're essentially saying there's no change or no difference. And in fact, if we were to put this into a hypothesis test, this would be a fail to reject because we're saying, look, there's no reason to change anything. Well, let's look back and see, oh, we did fail to reject. Right here, we sure did. That's exactly what we did. We failed to reject. So here's the clue. If 0 is in my 2 prop Z interval percentage, that's a fail to reject. So conversely, if 0 is not in my 2 prop Z interval, that definitely is going to be a reject. And let's look why. Let's say that this is not my interval. Let's say my interval ends up being 0.015 to 0.096, both positive. Then my conclusion would say we are 96% confident that the true proportion of parts within specification made by day workers is between 1.5% higher to 9.6% higher. We're saying it's always higher. They are not the same. And remember, my null hypothesis assumes they are the same. And we'd say, hey, no, they're not the same. They're higher. So I need to reject this and go with this, that they are actually higher or actually different. I think we were testing if they were different. So if 0 is not in the interval, because 0 is not, 0 would not be here, then we would reject. But if we got what we got, that it here is, then indeed it would be fail to reject. All right, I hope that helps you a little bit with 1 proportion or 2 proportion Z-test. I've also made a 1 proportion Z-test and interval video, and you can jump over to that one if you need to. Okay, let me know if you have any questions.